Good evening friends, study with the Pala Engineering and General Geology Parvin Singha book. So in chapter 12 जो कि study of rock है, igneous rock के बारे में study कर रहे हैं. The texture of igneous rock. The terms texture is defined as the mutual relationship of different mineralogical constitution in a rock. It is determined by the size, shape and arrangement of these constituents within the body of the rock. As will be explained later, a number of factors controls the formation of igneous rock from magma or lava. Thus, the process of crystals formations or crystallizations may be slow or rapid. The magma may be rich in one constituent and poor in other constituent, and further, it may be highly viscous or quite mobile, and so on. All these factors lead invariables to various shape, size, and arrangement of the resulting minerals, and hence produce a number of textures. फैक्टर इज एक्सप्लेनिंग टेक्सचर, जो कि फैक्टर है कि कैसे बना हुआ है, क्या क्या है. The following three factors will primarily define the types of texture in a given igneous rock. Degree of crystallization. In an igneous rock, all the constituent minerals may be present in distinctly crystallized forms and easily is recognized by unaided eyes, or they may be poorly crystallized or be even glassy or non-crystallized forms. The resulting rock textures are then described as holocrystallines. When all the constituent minerals are distinctly crystallized, holohyaline. When all the constituents are very fine in size and glassy or non-crystalline in nature. So the term Marocrystallines is commonly used to express the intermediate type is when some minerals are recrystallized and others are of glassy character in the same rock. Rock with the holocrystalline textures are also termed as pheneric, and the holohyaline rocks are referred as aphanitic. The term microcrystallines is used for the texture in which the minerals are receivable crystallized but in extremely fine grain. Granularity, जब granularity की बात करेंगे, this defines the grain size of the various component of a rock. These are the average dimensions of different constituent minerals which are taken into account to describe the grain size of the rock as a whole. Thus, the rock texture is described as coarse grained when the average grain size is above 5 mm. The constituent minerals are then easily identified with the naked eyes. Medium grained when the average grain size lies between 5 mm and 1 mm. So, use of magnifying length often becomes necessary for identifying all the constituent mineral component. Holocrystallines, narrowcrystalline and holohyaline. So texture of igneous under microscope. ये जैसे रॉक कट की गई, तो जब इसका फाइन स्ट्रक्चर हम माइक्रोस्कोप में देखते हैं तब इसी तरह का दिखता है. जब आप प्रैक्टिकल करेंगे तो और अच्छे से क्लियर हो जाएगा. तो नेक्स्ट पेज है फाइन ग्रेन. When the average grain size is less than 1 mm, in such rock identifications of the constituent minerals, grain is possible only with the help of microscopes, for which very thin rock sections have to be prepared for microscopic studies. Fabric. This is a composite term expressing the relative grain size of different minerals constituent in a rock, as well as the degree of perfection in the forms of the crystals of the individual minerals. The texture is termed as equigranular when all the component minerals are of approximately equal dimensions, and as irregular unequal granulars when some minerals in the rocks are exceptionally larger or smaller than the other. Similarly, the shape or forms of the crystals, which is best seen only in thin sections under microscopes, may be described as perfect, semi-perfect, or totally irregular. The textural terms to describe these shapes are respectively euhedral, subhedrals, and anhedrals. And igneous rocks may contain crystals of any one type is in a predominating proportions. Hence, its fabric will be defined by one of the following three terms related to fabric. Panidiomorphic, when the majority of the components are in fully developed shapes. Hypidomorphic, the rocks contain crystal of all the categories, euhedrals and subhedrals or anhedral. Allotriomorphic, when most of the crystals are of anhedrals or irregular shapes. Types of textures. After having known to various factors that define the texture types, it will be easy to understand the important textures as exhibited by the igneous rocks. These can be broadly divided into five categories: equigranular texture, inequigranular texture, and directive textures, in intergrowth textures, and intergranular texture. Following is a brief account of these textures of igneous rock. Equigranular texture. All those textures in which a majority of constituent crystals of a rock are broadly equal in size are described as equigranular texture. In igneous rocks, these textures are so by granite and felsite, and hence are also often named as the granitic and felsic texture. In the granitic texture, the constituent are either hence are either all coarse grained and all medium grained, and the crystals so euhedrals or subhedrals outline. In the felsitic textures, the rock is microgranular, the grains being mostly microscopic crystals, but these invariably is a so perfect outline. Thus, felsitic texture may be described as equigranular and panidiomorphic. Orthopyritic texture is another type of equigranular texture, which is between the granitic and felsitic texture. The individual grains are fine in size but not microgranular. Equigranular texture. Igneous texture is in which the majority of constituent minerals show marked difference in their relative grain size are grouped as in equigranular texture. Porphyritics and poikilitics textures are important example of such textures. So next page. The porphyritic texture is characterized by the presence of few conspicuously large size crystals, the phenocryst, which are embedded in a fine-grained ground mass of matrix. The texture is sometimes further distinguished into megaporphyritic and micropyritic, depending upon the size of the phenocryst. Porphyritic textures may be caused by any one or more of the following factors: difference in molecular concentration. When the magma is rich in molecules of a particular mineral, the latter has been better changed to grow into bigger crystals which may get embedded in the fine-grained mass resulting from the deficient component. Changes in physico-chemical conditions. Every magma is surrounded by a set of physico-chemical conditions like temperature, pressure, chemical composition, which influence the trend of crystallizations. Greatly abrupt and discontinuous change in this structure may result in the formation of the crystals of unequal dimensions. Thus, magma crystallized at a greater depth may produce a well-defined large-size crystal. When the same magma crystallizes with it, these large crystals move upward. The pressures and temperature acting on it are greatly reduced. Crystallization in the upper level of magma become very rapid, resulting in a fine-grained matrix, but that contains the big size crystals found earlier. Relative insolubilities. Some minerals constituents may be relatively insoluble in the magma than the others during the process of crystallization. Their crystals grains get enlarged, whereas the crystal of other soluble constituents get mixed up again with the magma. Thus, the relatively insoluble constituent forms the phenocrystal, and the soluble constituent make up the ground mass crystallizing towards the end. Poikilotic textures is characterized with the presence of fine-grained crystals within the body of a large-sized crystal. In other words, it is just the reverse of the porphyritic textures rocks like syenite, monazonite, and peridotites. It's commonly so these textures when the host minerals is identified as augite and the inclusions are of a plesioklist. So the poikilotic texture is further distinguished as opilitic. The development of ophitic texture in rock is yet incompletely understood. It may be due to operations of factors mentioned above for porphyritic textures, but in a different manner. In this case, the molecular concentrations of host minerals should be greater, and these should crystallize under favorable conditions only towards the end of the process, so that these are capable of enclosing many other crystals formed at earlier stage in the process. So this figure, electromorphic gabbro, vanadiumorphic cyanide, and hypidomorphic granite. So A indicate the structure augite, F indicate feldspar, and Fe iron oxide, and M indicate mica. Here M. So directive texture, so texture of igneous rock ये भी दिया, porphyritic texture, poikilotic texture, ophitic texture, ये भी एग्जाम में बहुत आता है. खैर ये तो है ही बेसिक बुक. Directive texture, those textures that indicate the result of flows of magmas during the formation of rocks are known as directive textures. These exhibit perfect or semi-perfect parallelism of crystals or crystallites in the direction of the following magma. The flow of magma. Trachyte and trachytoid textures are common example. The former is characteristic of a certain felsitic lava and is recognized by a palose arrangement of feldspar crystals. The latter is found in some cyanite intergrowth textures during the formation of the igneous rock. Sometimes two or more minerals may crystallize out simultaneously in the limited space, so that the resulting crystals are mixed up or intergrowths. This type of mutual arrangement is expressed by the terms intergrowth texture. Graphic or graphic texture are examples of the intergrowth texture. In graphic textures, the intergrowth is most conspicuous and regular between quartz and feldspar crystal. In the granophoric textures, and the intergrowth is rather irregular. Intergranular texture. In certain igneous rocks, crystals formed at an earlier stage may get so arranged that polygonal or trigonal space are left in between them. So these spaces get filled subsequently during the process of rock formation by crystalline or glassy masses of other minerals. The texture so produced is called an irregular texture. Sometimes the texture is specifically termed interstitial, and if the materials filling the space is glassy in nature. Thank you.